Okay, so today we're going to start our very last unit. This is the second part of chapter 7, and we're going to start off with the binomial theorem. And this is pretty important as you move forward in math, and especially if you ever join AP Stats, we work with this as well. So real quick, let's have you do the warm-up. So pause the video, and when you're done, you can check back to see how you did. Okay, so if we look at our answers here for those warm-up problems, okay, hopefully we didn't run into any problems on this. Okay, you should have had really no issue with them. First one, okay, just means x plus y times x plus y. And then what you saw I did in the second one is I took my answer from the first one and just multiplied by another x plus y. Now, you might never realize this, but there's actually a pattern for these terms. If you notice, in this first one, okay, the x to the second, that matches the exponent that we have. Here, x to the third matches that exponent. So your first term is always that x to the nth power, whatever power that is. And as we watch, in this next one, you see we have just an x to the first. Here we have x to the second. So the x's dropped down one power. So it became x to the n minus 1. And your y went up 1 degree. So y to the first. And then if you follow in this next one, again, x went down again from 2 to 1. So the next term would be x to the n minus 2. Okay, these aren't j's, sorry, those are just little semicolons. Okay. And then y went up again, so y squared. And we keep following that pattern. X keeps going closer and closer down towards 1. So eventually get x to the first. And y is getting closer and closer to n. And then we always end, if you notice here, with y to that power, y squared and y to the third. So this would end with y to the nth. Okay, so it's a little pattern to help you figure out what your terms are going to be in terms of your variables and your exponents. There's also a pattern with your coefficients. Okay, the coefficients of x plus y to the n follow the pattern called Pascal's triangle. Okay. So Pascal's triangle looks like this. So you start off with a 1 at the top, and then a 1 and a 1. Okay, so this would be your binomial to the 0 power to the first power, would just be x plus y. So x plus y, 1 and 1. Then we go 1, 2, 1. That's the second power. That matches what we did up here. And then we got 1, 3, 3, 1. That matches this example. And then it goes 1, 4, 6, 4, 6, or sorry, 1. And then it goes 1, 5, 10, 10, 5, 1. And you're probably sitting here wondering, where do these come from? Well, that next term below always comes from adding the 2 above. So the 1 and 1 came here to make a 2. 1 and 2 made the 3. 1 and 2 made that 3. 1 and 3 made the 4. 3 and 3 made the 6. 3 and 1 made the 4. And we can keep going down. Okay, so again, it's always starting off with, this is n equals 0 at top, n equals 1, 2, 3, and so forth as you go down. And that's Pascal's triangle. It can help you figure out what coefficients you're going to have on your terms. Another important thing we need to know before we move on is talking about something called factorial. We may have seen it this year, I can't quite remember. But this is factorial. This is that exclamation. So n factorial, that's what that means, not, woo, n, not getting excited there. So n factorial means n times n minus 1 times n minus 2, and we keep going till we're times just 1. Okay, so that's what n factorial is. So if I looked at like 5 factorial, let's look at an actual example. That would mean 5 times 4 times 3 times 2 times 1. Okay, there is a factorial button in your calculator. I'll post a video of how to get to that. Or you can just do that actual calculation and get 120. A couple of important factorials that you need to know are these two right here. 1 factorial and 0 factorial. These both are 1. Okay, so if you ever run any of those both are equal to 1. Okay, next one here, we're looking at an example. We need to use this problem here to help us solve this problem. So what we need to do is find what n is. So let's think about that expression on the left. That means n times n minus 1 times n minus 2, and keep going. Well, if you think about the bottom, this is n minus 1 factorial. So starting at whatever n minus 1 is, then times n minus 2, and keep going. So what's really going to happen there is cancel out all of that, and we just notice that we're left with n equals 5. Well, once we know n is 5, take that over here. That's 5 minus 2 factorial. So 3 factorial. 3 times 2 times 1, and that is 6. Okay, so we're going to see factorial because it is in one of our important formulas, and that formula is for combinations. Okay, combinations are something that's very important for figuring out the coefficients, and will also be important as we move towards the counting principle and towards probability. Okay, so combinations are talking about, you see this says NCR. If I have 10 items that I'm picking, R amount. So n items, R amount. How many am I going to pick from that group? So here it's saying I have 12 items, I'm picking 10. How many different combinations can that happen? Okay. You'll see it denoted a lot of times like this, n over R. And the formula for this is n factorial over r factorial times n minus r factorial. Okay. And again, n and r are non-negative integers. Okay. And r can't be any bigger than n. Okay, it will not work. So the example here, 12 choose 10. Okay, how many combinations of 10 can we make from picking from 12? So here's your n. Here's your r. So 12 factorial over r factorial, so 10 factorial. And then we have 12 minus 10 factorial. So we expand that. Now, I again will also post a video to show you how to do this in your calculator. But for now, we can do this by hand. We got 12 factorial over 10 factorial times 2 factorial. And you might be sitting there, well, I got to do 12 times 11 times 10, all that. Well, think about this. That top part is really 12 times 11 times 10 factorial. So we actually get those to cancel out for us. And if you think about this 2 times 1, that's just 2. So that can cancel out with a 12, make the 12 become a 6. And we end up with just 66. So what that means is we actually have 66 different combinations if we pick 10 items from a group of 12. Okay, now the two things we talked about here, factorials and combinations, are going to play a huge role in helping us find our coefficients quickly. All right, so now we'll move on to actually talking about the binomial theorem. And when you take a first look at this, you're like, wow, that's a lot of stuff going on there. This looks really complicated. But you're actually going to find out if you have x plus y to some large exponent, this is going to save you a lot of time. Okay, so anytime you have something that is x plus y to the n, it always follows the form of your first term is x to the n, whatever your exponent is. Your next term is n choose 1, x to the n minus 1. So we're going to drop 1 degree on the x, and we're going to add a degree to the y. Then we go to n choose 2. Take away another degree on the y, or x, add another on the y. And we keep going until we eventually get to n choose n minus 1. X is just the first power, y is to n minus 1, and finally we end with just y to the nth. Okay, and you'll wonder, why is there nothing in front of these first and last terms? Well, this is really just n choose 0, and this is n choose n. Well, if you have 10 items, how many different ways can I pick 0? There's just one way. I don't pick any. And the last part says, if I have 10 items and I pick 10, there's only one way. I pick them all. Okay. So we're going to see this in work, in an example here, and it'll make a lot more sense to you. So instead of x and y, we're using m and n. So we start off with our first term, m, and that's going to go to whatever power we're being raised to. So in this case, it's the fourth power. So m to the fourth. Plus, okay, now we got n choose 1. Well, our n in this problem is 4, so 4 choose 1. We're going to drop 1 power on your m, so it becomes m to the third. And we're going to add 1 power to our second term, which is n, so n. And then we go to 4 choose 2. Take a power away, add a power, so m squared, n squared. Okay, we go to 4 choose 3. Take another power away from the m, add it to the n. And again, if you do 4 choose 4, that's fine, but you're going to realize that now we're just 4 choose 4, which is 1. Your m's going to lose another power, so it's gone. And your n is going to go, oops, sorry, that's supposed to be a 3 there. Your n's going to go up 1 more power to get to n to the fourth. So as I notice here, my m goes 4, 3, 2, 1. My n goes 0, 1, 2, 3, 4. Okay. And then from there, we do need to simplify. Okay, so I would have m to the fourth. I have 4 choose 1. I have 4 items. How many ways can I pick 1? Well, there's 4. I could pick this item, the second item, the third, or the fourth. Now 4 choose 2. Maybe you don't know what 4 choose 2 is. You probably won't. So if we go and do 4 choose 2, remember that's n factorial over r factorial times n minus r factorial. Which in this case, 4 times 3 times 2 times 1 over 2 times 1. And this is 2 factorial again, so 2 times 1. So cancels. Okay, the 2 reduces that 4 down to 2. And so we just have 2 times 3, which is 6. So this right here becomes 6. 6m squared n squared. Okay. Again, if you want to do it for 4 choose 3, but you're going to notice there's this reflexive property. Okay, you know the 4 choose 1 and 4 choose 3 are actually the same. And if that's thinking about your Pascal's triangle and n to the fourth. So with that example, if you think about Pascal's triangle, which was 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay, so again, that first one's to the 0 power. So 0, 1, 2, 3, 4. Okay, and moving on to our last example here, you'll notice there's a couple differences here. Now our exponent's a little bit larger, but you'll also notice that there's a number in front of the b. Okay, so that is the term. We have one term is a, and one term is negative 2b. So again, always starting with the first term to the power, so a to the 7th. Okay. And as we move on, okay, it's the power for n, and then choose 1, then choose 2, choose 3. So we're going to start off with 7 choose 1. The exponent for your a is going to go down 1. And then we're going to add an exponent to your next term. So negative 2b to the first. Okay, then we go 7 choose 2. The a goes down a power. The negative 2b goes up a power. And we keep following that trend. Okay, we go 7 choose 3. A to the fourth times negative 2b to the third. Then we go 7 choose 4. A to the third. Negative 2b to the fourth. Hopefully we fit everything in here. Okay, we got 7 choose 5. A to the second. Negative 2b to the fifth. Again, your exponents should add to 7. Make sure you're always doing that right. So 3 and 4 are there. 2 and 5 are good. Then we got 7 choose 6. A to the first. Negative 2b to the sixth. And then the last one is just your final term to the nth. So negative 2b to the 7th. And you're going to sit there and be like, wow, this is a lot of work to get that all set up. You're going to see that this is going to be a lot quicker than if you were going to expand and do a minus 2b times a minus 2b times a minus 2b over and over and over. Okay, so we are going to do a little bit of simplifying here. Okay, so we're going to have a to the 7th. Still stays there. Okay. 7 choose 1 is just 7. Okay, so this isn't going to change at all. It's 7 a to the 6th negative 2b. So not changing that at all. Okay, if we did 7 choose 2, if you use your calculator, you're going to find out that that is 21. A to the 5th. And you got to be careful here because we actually have to do negative 2b squared, which is 4b squared. Then 7 choose 3 is 35. A to the 4th. And then negative 2b to the third is negative 8 to the third. Negative 8b to the third, sorry. Okay. And then we have another 35. And that's a to the third and 16b to the fourth. Okay. Go to our next term. We got 7 choose 5. 7 choose 5 is 21. A squared, and that gives us negative 32b to the fifth. 7 choose 6, that's just 7a, and then negative 2b to the 6th is 64b to the 6th. And then our last one there, negative 2b to the 7th is a. Okay, so this is the expression we left there. Now all we got to do is go back and simplify. So look at the first term. It says it's a to the 7th. Next term, 7 times negative 2, so negative 14. A to the 6th, b. We go to our next term, 21 times 4, so that's 84. A to the 5th, b squared. Then we got 35 times a negative 8, that's negative 280. A to the 4th, b to the 3rd. And again, see how I'm underlining those is making sure that you're staying on the right term. We got 35 times 16. That gives us 560. A to the 3rd, b to the 4th. And I got 21 times a negative 32. That's negative 672. A squared, b to the 5th. You notice we're alternating signs, positive, negative. I got 7 times 64. Okay, so that gives us a positive 448, a, b to the 6th, and then we have our last term of minus 128, b to the 7th. So again, you'll notice we're alternating positive negatives there because when we're squaring that negative 2, or raising the exponent, it changes from positive to negative. And notice, quick check is it's a to the 7th, 6th, 5th, 4th, 3rd, 2nd, 1st, and gone. And my B's went 0, 1, 2, 3, 4, 5, 6, 7. That's a really quick check. Make sure your exponents are in order. And then your numbers, your coefficients there. Just got to be very careful with your signs and entering those incorrectly. So big thing is make sure you check out the calculator.